Hi, we're going to move on to create a histogram, and we're going to create a histogram in order to continue to assess the normality of our data. And again, normality is an assumption for many tests that we're going to run. In SPSS, there is an easy peasy way to run the Shapiro-Wilk test, which enables us to assess normality with the click of a button. In Excel, we're doing this in somewhat roundabout ways. We looked over here, up here at our descriptive statistics before, we saw that the mean and the median were somewhat close to each other, which is a characteristic of normally distributed data. And we saw that kurtosis and skewness were close to zero, but there was a slight departure. Whether or not the slight departure is statistically significant or not, we're not sure. So we've eyeballed it. We might have tentative evidence for normality, but another way we continue to assess for normality is through creating a histogram. So we're going to do this the long way on the Mac version of Excel. So we're first expected to create bins, and bins indicate the range of my data. And I want to create bins here from what looks like my low value, 25, to my high value, 36. So I'm going to create bins starting with 24, an interval of 2, and going all the way up to 36. And so I'm just going to drag and drop these to make life a little bit quicker. And there I have my bins. Now I need to know the number of my data points that fall between these intervals. So the bin 24 will catch anything that's less than 24. We're going to expect this bin to be filled with 0 because we know our minimum value up here is 25. 26 will capture the frequency that the data points 25 and 26 appear. 28 captures the number of times that 27 and 28 appear, etc. So here's how we're going to do that. We're going to highlight all these cells, and up here in our function bar, we hit equals frequency, open parentheses, and we're interested in D2 to D51, comma. Our bins here are in column F. We close parentheses, and then we're going to hit Command Enter. And there, that's our frequency distribution. Now to turn this into a histogram, we're going to highlight these values, go to Column, and Clustered Column. This is our histogram. Easy peasy. If we want the bars to be right against each other, the way histograms are often drawn, we need to, let's see here, format the data series. And then we go to options here. We're going to reduce the gap width to 0. And we click OK. And that's the traditional histogram. Now let's look at this histogram. It doesn't really provide us any new information. We knew all along that on the basis of our skewness 0.288 that the histogram would be positively skewed, which it is. This tail to the right is a little bit longer. We also knew, because of the kurtosis value of 0.69, that it was going to be a peaked distribution, and we see that it is a skinny curve, that it rises and it falls quickly. Is this normally distributed? I would say it's good enough. We know that t-tests and ANOVA are pretty robust. There are other ways we could drill down to further explore normality in Excel. I think those are probably a bit more detail-oriented than what the average social work practitioner would need. If you're interested in drilling down further, I'd probably suggest looking into SPSS. But for now, I think that looking at skewness, kurtosis, the alignment of mean and median, and looking at the histogram is probably good enough to say that it's good enough to go on with the very robust t-tests and ANOVA. That's it. Thank you.